And today I'm going to talk about delivering media and entertainment using the AWS cloud. So the agenda that I've got is first to talk about some of the challenges that media and entertainment customers are facing in today's market. Talk a little bit about AWS media solutions and how customers use those solutions to build and provide solutions to their customers. And then I'm going to run through 8 media workloads and identify customer case studies that are running on AWS. So the first thing to talk about is the changing of consumption of content. So you can see from this graph, the traditional way of consuming media and entertainment, particularly around television, through cable, satellite, digital terrestrial, is reducing. And over time, what's taking over is the streaming of content. You've also got the difference of people not necessarily buying their television through their television provider. They may still continue to consume the broadband internet connection. For the actual television themselves, they're going over the top and they're selecting skinny bundles. Skinny bundles are where rather than buying lots of TV channels, they're being very selective in the TV channels they want. And also, they're changing those channels month by month, so they're not tied into a long contract of 12 months. They can change every month and select which TV channel that they want to consume. This makes the market much more agile and changing all the time. These TV channels have to appeal to these consumers all the time to attract their custom. There's also a change in advertising revenue. Advertising wants to be able to target advertising to specific users. Traditionally with TV, you'd select the advertising based on the program that the adverts were delivered within. But now they want to target specific users watching that content. So the big changes we see are new content providers such as Netflix, Amazon Video, but also traditional broadcasters like the BBC changing and delivering more content, even exclusive content online, perhaps even before they deliver it via the traditional broadcast methods. We also see these technology companies such as Facebook, Apple, creating content themselves, Amazon Video as well, creating content. But also the studios, the movie studios, the content providers themselves being more involved in technology and delivering this content to the end users directly rather than going through a third party. So some of the challenges that we'll see. One is the cost pressures. They want to map the cost of delivering content much closely to the revenue that this is generating. Content varies over time. You may be delivering a really popular program, you need to provide more compute power, but then they want to scale down during the quiet times. Content itself is getting larger. We're moving to Ultra HD, 4K, 8K. The video content itself is getting larger, more complexity for storing that, and also for processing and transcoding the video. There's also a variable demand. As I mentioned, that you have these events, these new programs being launched, and handling that capacity, delivering a whole series of content in one go for people to binge consume that content over a matter of days, means that to predict that consumption is very hard, it's very peaky, and changing all the time. There's also competitive pressures. So the traditional broadcasters obviously competing against themselves, but then you've also got newcomers into the market who are quite often targeting specific groups of users. And with the benefit of skinny bundles, users can pick and choose which channels they want. Competition is gradually increasing over the whole industry. Now, traditionally, with many broadcasters, they would deliver content to a specific country or a geographical area. Now, with the ability to deliver to a global audience, that makes cloud more important. It's very hard to produce and manage data centers globally, whereas with the cloud and with AWS, you're able to deliver that content to a global audience without the expense of creating new infrastructure. And also, for broadcasters and content providers, IT is not their core competency. Their core competency is creating content and creating a user experience that is engaging with that user and provide the entertainment. So this is some of the AWS media customers. These are public references that we have. Just to point out a few that are based here in Europe. The Guardian is a UK newspaper. They provide a lot of content online using their app and their website through AWS. We have the BBC providing iPlayer, the Financial Times, and Endemol as well. So if we look at some of the AWS media solutions, the first thing to see is many of our AWS services may not necessarily be specific to media, but they'll be used in the media processing. So if you look at ingesting content, getting the content into AWS, whether that's by a file or a live video feed over IP, our services such as Direct Connect, private network connection with your data center and AWS, using Snowball for physically moving archive content into AWS, or using S3 transfer acceleration, where you use the AWS Edge network to accelerate transfer content both in and out of S3. For compute, we've got EC2, our virtual servers, but also we recently acquired a company called ThinkBox that provides ThinkBox Deadline, a way of managing your render pipeline when you're generating video effects. For processing, so for video transcoding, we've got Amazon Elastic Transcoder, a service that is a fully managed service and provides transcoding for web delivery. But also we've got AWS Elemental for providing live and on-demand transcoding, and origin services for delivering content over the internet to your users. For storage, we've got our object storage S3, Glacier for our archiving content, and also EFS, our file shares, and EBS, our volume storage. For delivery of content to web users, Amazon CloudFront is a content delivery network, caches your content and accelerates delivery to your end users, reducing the latency and improving performance, whilst also reducing the cost of your origin servers. And then for analytics, we've got Amazon Machine Learning, EMR, and other AI services. Now, I briefly mentioned AWS Elemental previously. So AWS Elemental is a company that we acquired beginning of last year. They provide services both in the cloud, called AWS Elemental, as well as virtual appliances and physical appliances that you can run in your own premises. So they provide services such as file transcoding using Elemental Server, live transcoding called Elemental Live, Elemental Delta, which is a smart origin, which acts as the origin to your content delivery network, and a few other services such as StatMuch, which is a very specialized service for providing the ability to transcode your content to fit a specified bit rate. This is normally used for things such as satellite uplinks. So as I mentioned, this is available in the cloud using AWS Elemental Cloud, physical devices that you'd run on premises, and also virtual appliances where you can run as virtual machines. So AWS Elemental customers work across different industries. So you've got the paid TV operators such as BT, content owners such as HBO and Turner, broadcasters like the BBC, TF1 and NDR, and then also corporate and education customers as well. So another company that we acquired beginning of this year was ThinkBox Software. They provide a render management software called Deadline. This is used in the video effects industry, the ability to manage your render farms, to render the video over a number of EC2 servers. It also provides a marketplace, similar to the AWS marketplace, but specified specifically for the video effects industry. So many of the video effects software that the customers use, they can use the software through the ThinkBox marketplace and then pay as they use it, allowing them to scale up to run a render job and then scale back down, and saving cost on licensing and also on EC2 usage. So we find customers use AWS differently depending on their requirements to provide their media services to their end users. So people will use Aws Elemental for transcoding video files, or they may be using ThinkBox for their video effects workloads. But then there's many partners of AWS that provide solutions that run on top of AWS. The software solutions that customers have been working with and experienced with for many years, they can run that on AWS Cloud. And then many customers will build their own solutions from all the individual components, third-party software, using perhaps through our AWS Marketplace or open source software. And all these solutions are running on the building blocks of AWS, the compute, the storage, networking, etc. So within the media ecosystem of AWS partners, we offer partner solutions for different things, from ingest all the way for delivering content, and then also the system integrators to build those solutions for you. And there's many different types of media software in the AWS Marketplace. This allows you to spin up virtual machines to run the software that perhaps you're used to and that you're most comfortable with, and it's the one that you find the most valuable. But you can run that in AWS and pay by the hour that software consumption your AWS account. So next, to look at the media workloads. So we've identified 8 media workloads, going from ingestion, which is where an acquisition where you're pulling content into your workloads, from post-production, which is creating content, whether that's through video effects rendering or modeling or editing video. DAM and archive, so that's storage of your content, perhaps for a long term of content. The media supply chain, where you're readying that content for distribution. Publishing that content, whether that's video or whether that's articles for a newspaper. Playout and distribution to your broadcast systems such as satellite and cable. OTT for delivering content over the top via the web. And then finally, that feedback loop back into the system for analytics, whether that's analytics of user consumption or analytics of the system itself. So content acquisition. The key thing is acquiring content either via live IP stream or via file-based media. As AWS, we can only handle IP content. So if you have content that's available via satellite, for instance, or via video feed, you can work with our partners to convert that into an IP feed that you can then feed into your AWS account for processing. So one of our customers in the US called Scripps, they manage many different TV channels, own many different TV channels, and they needed to move a lot of content into AWS Cloud. So they used AWS Snowball to move that content onto a physical device to ship that into the cloud. It's a lot quicker moving devices often than having an internet connection, so it's a quick way for them to get their archive into the cloud. So production and post-production. So often this is compute intensive, whether that's you're editing video files or you're generating video files, rendering video files. They're usually compute intensive, both for CPU and GPU, depending on the software that you're using. You've also got to often give the ability for people to do what we call edit in the cloud, the ability that they can log into a remote desktop to do editing of the video file in the cloud rather than downloading the video file, doing the editing and uploading. It's far more quick if they log into a machine that's close to that video content and perform the editing actions there and save that content directly back into the cloud. So one of our customers called Barnstorm and Theory Studios, they had a requirement to run rendering jobs for a video workload. It was actually for Amazon Video, Amazon Studios for Amazon Video. So they had a requirement. They operate a virtual studio where the artists that are creating the content are spread across the whole of North America. They don't have a physical building where everybody has to be in. They're spread across remotely. But by using the AWS Cloud, they could treat the cloud as their studio. So the users could manage the content, model their video effects rendering content, And then running that on EC2 spots, so be able to bid for that compute power to run those render jobs, and also using ThinkBox software deadline to manage those render farms. So once they've rendered the content, they can switch that off and stop paying for the content. They only have to have a render farm running when they're actually doing the rendering. So the next thing to talk about is digital asset management and archive. So this is where you're ingesting content into a storage. Often it could be for decades of storage content, or you may be only for a short term whilst you're creating the production. Digital asset management allows you to tag that content, extract metadata from it, be able to preview the content before you download it perhaps, or move it into another system, but also to be able to search for that content. So one of our partners, Vidispine, they're based in the Nordics. They provide an API for asset management, and they recognize that digital asset management is very tricky to build a one product that fits all. Every customer has their own specific requirements around digital asset management. So Vidispine built this very rich API on top of different services that allows customers to then build their own specific user interface to support their particular workflows. Next is the media supply chain. So this is where you've created the content ready for distribution, but you need to do some process on it, such as transcoding it to the final versions, perhaps adding subtitling, processing, ready for delivery to the end, downstream for final delivery to the end user. So one of our customers is Sony DADC New Media Solutions. And their customer, one of their customers is BBC Worldwide. So BBC Worldwide is the commercial arm of the BBC in the UK, and they're responsible for managing the rights and selling rights of BBC content to the international market. So Sony DADC provides a solution called Venue for customers to manage the rights and the delivery of content when they license content to international customers. This allows a single location for this content to be hosted, and then managing the rights, these can be distributed to the individual broadcasters around the world. Now, they had a challenge, Sony did, of managing all this not in the cloud, but by using the cloud, it allows them to manage the content. They can scale the content hosting and the delivery, but it also gives a central location. Many broadcasters around the world are in AWS, so it makes it very easy for them to transfer content from the Sony platform into their own platform for distribution themselves. Next is OTT, Over-The-Top Delivery. So if you think about this, traditionally, you would buy your TV channels through your TV provider, whether that's cable, satellite, digital, terrestrial. Over-the-top is really going over the top of those TV providers and delivering it over the internet. You know, maybe over their own internet connection that you're buying from the same provider. But it allows you to choose which providers of the OTT service you want to choose. Now, many of these TV providers are also OTT providers as well. So the challenge with OTT is, whereas in traditional broadcast, the standard for television is very specific, OTT varies greatly because you've got many different devices supporting many different protocols, resolutions, codecs. You've got old devices as well as new devices, old devices that aren't being updated as often as some others. So it's a real challenge to manage potentially hundreds of different device types to deliver that content to your end users. So probably one of the most vocal of AWS media customers is Netflix. So Netflix, a few months ago, were fully migrated into AWS. So they use AWS for the fully the media supply chain, the transcoding, and the delivery of content to their own CDN, which is built within individual ISP networks. But all the website is being hosted on AWS, and they manage the whole workflow on AWS. As well as that, we've got Amazon Video. So Amazon Video is a part of Amazon, but equally, they can choose who they work with. And luckily for us, they work on AWS, they run on AWS, again, both the media supply chain and the delivery. So they provide video-on-demand content, but they also launched Amazon channels, which are live linear channels as well. So they launched that service in Germany and the UK a few months ago. And this is an architecture that they use. So they're using AWS Elemental Cloud for the transcoding. And they provide the video, they take the video feeds from their partners, the broadcasters, the TV channel owners, move that through AWS Elemental Cloud for the transcoding of the content. And what they do is they operate across two different AWS regions, one in Frankfurt and one in Dublin. And they deliver those channels both to the UK and to Germany. But by using both regions, they're able to, if there's a problem with one particular transmission feed of a particular channel, they can fail over either within region or go across to a different region if they so wish. Another customer is the BBC. So they had a challenge a few years ago where they were delivering their prime channel, BBC One. So BBC One is a national TV channel, but 3 times a day, it breaks out into 18 regional channels for regional news programs. And their challenge was that they're transcoding this content live and also providing video-on-demand catch-up of these content. So they had a challenge where they would go from 1 channel to 18 channels 3 times a day, but only for between 10 and 30 minutes at a time. So they had the challenge was to scale their infrastructure when they were on premises to manage this. But by moving to the AWS cloud, they were able to spin up new instances to manage these extra channels and able to turn around the catch-up VOD assets within minutes, whereas previously it could take hours to deliver those regional news programs. So they're running iPlayer in AWS now, both managing the content stored in AWS, as well as the APIs and the website for iPlayer. Next workload is playout and distribution. So this is where you've got the content, but you're going to distribute it to traditional broadcasts. So as I mentioned before, satellite, cable, digital, terrestrial. So playout is, in effect, you're taking a playlist of video content, whether that's TV programs, adverts, clips, and also live inserts. You're taking that playlist and you're combining those files and those live feeds into a single stream that you play out to the satellite or the cable provider. Now, typically this is very challenging because you've got a single feed. It's not like HTTP web services where the actual transactions are quite short-lived. It allows you to scale and auto-balance and provide high availability. The high availability is typically built within the actual playout server itself. You might often have 2 separate playout servers, but you have to physically switch between the video streams. So it's a challenge to do in a virtual environment. And a lot of these playout servers, it was only a matter of years ago, they weren't even running virtually. They weren't even running TCP/IP. They were running their own protocols, their own hardware. So recently, many of the providers of these playout software have now virtualized and providing cloud solutions. And one of our customers is Discovery Communications. So they're using a vendor called Evertz, who provide broadcast playout solutions, and they're running that in AWS Cloud. Again, they're running over 2 regions. They're providing solutions globally. So they're running in 2 regions, one in Europe and one in the US. And they're delivering these playouts of these channels back down to their premises, where they're actually doing the switching if there's a failover. But they're running it all in AWS. So the content is stored in AWS. They're replicating between S3 buckets using S3 replication. And they're running G2 GPU instances on EC2 to actually manage the playout, the actual graphics part of the playout. Next is talk about digital publishing. So this is traditionally newspapers take a long time to obviously create the content, print the newspapers, and distribute it. But newspapers, the time to turn around stories is shortening and shortening, especially online. So they want to be in the situation where they can adapt and be agile in their web publications to be able to update news stories and change those news stories and get feedback from their readers to understand what our readers are interested in and adapt and change those stories. So the Guardian newspaper in the UK, they had a challenge of being that agile in their traditional infrastructure. But by moving to AWS, it allowed them to increase the rate of when they can deliver new versions of their application and speed up that time to innovate, to be as fast as possible and be able to make changes to their system a lot more quickly, and also be able to scale on demand. If there's a breaking news story, they can scale out to handle those requests coming from their readers. Next one to talk about is analytics and AI. So you can think of analytics and AI, traditionally it's quite often thought about, consumption of users, what they're consuming, what they're watching, what's their interest. But I like to think about analytics as being the whole system. So don't really focus just on one particular area of consumption by users, but think about using analytics for the whole process, the whole workflow of all these 8 media workloads. So in the UK, we've got Channel 4. So Channel 4 is a commercial broadcaster. So they're ad-funded. So their revenue is generated from the advertising. Traditional broadcasting is very difficult to generate great value of advertising. Although you get large audiences, it's very hard to know who is actually watching that content. And advertisers like to be able to target individual users or individual small groups of users based on their demographics. For Channel 4's online delivery of their OTT web platform, they were able to use Amazon EMR, Elastic MapReduce, our managed Hadoop service, to be able to generate these targets for the advertising, increasing the value of those advertising, and therefore increasing the revenue for Channel 4 by just targeting those adverts to specific groups of adverts in the online delivery. In Amazon AI, if you think about it, you've got the basic infrastructure, building blocks at the bottom, so things like compute, whether that's CPU or GPU, or using services on top of that. So the ability to build using the Amazon machine learning, AI AMI, the ability to run Apache MXNet or TensorFlow specifically to your deep learning or artificial intelligence applications. Or whether you want a more managed solution, so using Amazon machine learning, or even higher than that, very specific services targeted to a particular use case, such as Amazon Recognition for image recognition, Amazon Poly to create a text-to-speech service, or Amazon Lex, where you create a chatbot. So depending on your needs and your requirements and how sophisticated you want the service to be, or whether you want to get in and create your own artificial intelligence application, you can choose at what level of the stack, of the Amazon AI stack, that you want to choose at. So there's an example. C-SPAN in the US, they provide a lot of coverage for Congress in the US and government meetings. So they had a requirement to be able to index that content, to identify who's speaking in that content. So they use Amazon Recognition to analyze the faces of the speakers and then compare that to their own database of Congress people, members, and match those against that database of images to be able to index that content and identify with a time code when that person spoke and be able to tie that with the transcription of what they actually said. So as I mentioned before, try and think about artificial intelligence and analytics as being across all the 8 workloads. Don't focus just on the traditional side of recommendations engines or analyzing user consumption or the quality of their experience. Think about adding it in a whole of the workload. So for instance, be able to extract metadata from the video source. Typically, a lot of the metadata is captured by humans, typing in at a console what's happening in the video. But imagine using deep learning to be able to extract metadata automatically, be able to index a particular car in a scene or who is famous in a particular scene, identify all that index. You can do that right early in the workflow, reducing the costs of having to employ humans to actually manage all that typing and all that content. You can also use it managing the services themselves to identify any particular content coming through. If there's a problem with the content for quality control, if it's black and missing or it's missing the audio, you can identify that earlier on in the workflow, again, making it streamlining your workflow by using artificial intelligence. You can think of artificial intelligence creating this flywheel effect. The fact that you've got content or data, by having this data, it can allow you to make those decisions about what content to create, which TV programs or movies to greenlight. By having that data, it means making those more informed decisions. That can flow into the fact that your content increases, the quality of your content increases, the more attractiveness of your content increases. That will inevitably mean that your audience increases. By the fact that you've got more consumption and more engagement with your audience, that can feed back into generating more data. And so the flywheel continues. The quality improves of the content. You get a larger audience. You collect more data that allows you to make more specific decisions about your content next time. So that's all my slides I've got. I have a few minutes if you want to take any questions now, or I will be at the outside if anybody has any questions. Thank you.